day I was working with someone and we were discussing how to do physics problems. And so I'm actually going to do this one in the way that that person suggested, because it is something that we don't necessarily think about. So we have a woman at an airport, which is kind of fun because we got some folks that are about to be going to the airport, is towing her 16.0 kilogram suitcase at constant speed by a pulling strap. I'm actually writing out the whole question. By pulling, let's scratch that, on a strap at an angle theta above the horizontal. She pulls on the strap with a 36.0 Newton force, and the friction force on the suitcase is 20 newtons. Okay, so I wrote out the whole thing, and typically when I'm doing a problem in class, I haven't been writing out the whole question. And one of the tips that Dr. Hagib pointed out, he said, why don't you read the question first and ignore the numbers? And I just got finished listening to a book about making numbers count. My daughter is an equestrian and is a very talented equestrian. Her degrees are all in equine management and mass communications. So my daughter would tell you flat out she's not a numbers person. And we experienced that when we were dealing with doing algebra and general numbers and stuff. And you would ask her, even back in elementary school, you'd ask her, what's 3 times 5? And she'd look at you like you were, the proverbial lobsters coming out the ears. 3 times 5 meant absolutely nothing to her. But you tell her, we're going to be gone for 5 days. How many pounds does your horse have to have? How many pounds of food does your horse have to have if your horse is eating 3 pounds a day? How much food do we have to have that set out? 15 pounds. I mean, instantaneously would tell you exactly how many pounds. But you asked her 3 times 5, wasn't happening. But you told her you're going to be gone 5 days and the horse had to have 3 pounds of food, she'd look at you like 15 pounds. She does worm medication, weird, complex, the horse is 900 pounds, has to have X milligrams, and she'll do that calculation instantaneously, but if you just give her the numbers equation, not happening. That is not the way, and our brains are actually not designed for numbers. In fact, when you go out there and you're counting for those biology types, and you're going out there and you're counting cows in the pasture, we actually count groups. We said, well, there's 3 cows there, there are 4 cows there. We actually assign numbers to them. So he actually said, read the problem without the numbers to get an idea of what it is that you're really looking for. All right? And so basically what we're going to do with this one is, first of all, bothering to draw the free body diagram. That's what the problem asks us to do. But we also want to know is what is the angle that the strap is making with the horizontal, and what is the magnitude of the force that the ground exerts on the suitcase. So that's what we're trying to find out. We're trying to find out what's the force that the suitcase is going to do on the ground, and what is the angle that we've got. Okay? So he says, read the problem without the numbers. So we got a person towing a suitcase at a constant speed. And we're pulling on the strap, and the strap is making an angle with the horizontal. And we know what the force is that the person is pulling on, and we know what the force due to friction is. And what we want to know is what is the magnitude of the normal force the ground is exerting on the suitcase. So, we've got the problem. So now we're going to take this problem and we're going to draw our picture. Okay, we're going to draw our picture. And you could draw your picture, this time they gave us our little suitcase, we got our person, and we all know my lovely artistic abilities here. We have a person that's doing the suitcase. So that's kind of the situation that we have, but let's draw it as our free body diagram. So we have our force due to gravity of the suitcase, which is going to equal the weight of the suitcase. We have the normal force that's being applied. We have the force on the strap. And we're told that it's making an angle from the horizontal, so we're going to draw that picture. And we have our force due to friction. So now we've got the picture of what's going on. So then he says, okay, read the problem again. We have a woman at the airport is towing her 16-kilogram suitcase. So if this is mass times gravity, we know that we have our 16 kilograms, and we have our 9.81 meters per second squared. So we've got a given, and we can go ahead and calculate the force due to gravity. We can do it right there in our picture. So we're essentially labeling our picture. So this is 156.96 newtons. We don't have the angle, okay, that's all right, but we know the magnitude of this force. The magnitude of this force is 36 newtons. And we've got the magnitude of my force due to friction is 20 newtons. So our givens, we can write down our givens as we have our mass, which was 16 kilograms. We have our force due to friction, which is 20 newtons. And we have the force on the strap, which is 36 newtons. We want, what the problem is asking us, we want to find out the angle, and we want to find our normal force. So now let's figure out some things on the toolkit. Okay, well, our toolkit for this one is really that the summation of my forces are going to equal mass times acceleration. But we also know that we're going to have a summation of forces in the x direction, and we're going to have a summation of forces in the y direction. And one of the givens that there are a couple of givens, and I'm going to actually write these in a different color, because we're given a couple of other pieces of information. And this is one of the funny things that Dr. Hagib said yesterday that I was kind of laughing and chuckling about, because it depends on the person. But usually when we're dealing with a book or a problem in the book for homework, there's a reason why we put the words in there. Most of the time we don't put extraneous stuff. Sometimes we do put extraneous stuff. partially because there's more than one way to do the problem and that extraneous stuff can help us. So that's one thing, okay? The other part of this is that there's usually meaning to the words that they're putting in there, which also means that if I've got something in the book, unless I give you an answer that says not enough information to do the problem, usually if we've left something out, you don't need it. So that's something else to think about when you're dealing with the problem. But we're given two other pieces of information, but it's not jumping right out at us. One of the pieces of information that we're given is our acceleration due to gravity. The other thing that we're given is that my acceleration in the x direction is equal to 0. That piece of information was given by this statement right here, that we're at a constant speed. So they gave us that piece of information. They give us this piece of information because we're 7 weeks into the semester, and by now we should know that the acceleration due to gravity on Earth is 9.8 meters per second squared, or if we're in feet per second, it's 32 feet per second squared. And so they feel like we don't have to give you that information anymore. So that gives us back to our toolkit here. And our toolkit is saying, all right, so now when we're going to look at this, this is our mass times our acceleration in the x direction. That's equal to 0. Since we're calculating our normal force, it's also kind of telling us our mass times our acceleration is equal to 0. Because we're really not doing anything in our free body diagram that's telling us anything different. So now we've got two equations to work with. Pretty cool. The other thing we know we're going to have to do, and part of this is, and these are the things that, when you don't know how to start a problem, these are things that you can do to get your brain thinking and working on stuff without while, if you've already done this, you drew your free body diagram, you got your givens, and you started labeling things, guess what? You're going to get points on the test. You've drawn your picture, that's at least 1 point. You've got things labeled, that's another point. You've written out and you've done a couple calculations, hey, I got that stuff done. So now the next thing let's do is, let's go ahead, we know we have a force that we're going to have to play with, right? So we're going to have to do this. So my force on my strap is going to equal 36 newtons cosine of my angle. We don't know the angle, but we're going to write this out in vector notation. And I've got 36 newtons sine of the angle. So now I've got my strap, the force is there, because we're going to come down and we're going to do our summation of forces in the x direction, summation of forces in the y direction. Okay, so let's do that. I'm going to do it this way so that we can continue to play here. So there's our picture. There's our picture. All right, so we already figured out that our toolkit says sum of the forces in the x direction has got to equal 0. So now I'm going to look at my forces in the x direction. So I have the force of the strap in the x direction plus my force due to friction has got to equal 0. Now, if I put this in there, my force due to the strap is 36 newtons cosine of the angle minus my force due to friction, because it's in the opposite direction, is 20 newtons. Well, that's pretty cool because I'm going to be able to solve for the angle. That's all right. So I've got 36 cosine of the angle is going to equal 20. Cosine of the angle is going to equal 20 divided by 36, which I can go ahead and put into my calculator. And that's going to give me a 0.556. So my angle is going to be the arc cosine of my 0.556. And now I've got 56 degrees, 56.3 degrees. So we've been able to figure that out. That's pretty cool. Now we want to know what the normal force is. Well, that's going to take the sum of the forces in the y direction are going to equal to 0. That's going to be, and I'm going to write it out in terms of words rather than doing our symbols. That's going to be my normal forces in the up, and I'm going to subtract off the weight. So I've written this down in words rather than in our traditional physics jargon. And our traditional physics jargon then would say this is the newtons minus my force due to gravity. But we have another force in the y direction. Oops, I forgot that one. So I've made a mistake. So we're going, wait a second, there's a third force in the y direction, and that third force in the y direction is due to my strap. So we're going, oops, made a mistake, got to do this again. So let's look at my sum of my forces in my y direction. I've got my normal force minus my weight plus my force due to the strap. So now we can do this. I've got my normal force minus the force due to gravity plus my force due to the strap. That's all got to equal 0. So if I put in things, I'm going to solve for normal force. So my normal force is going to equal my force due to gravity minus the force of the strap. This is equal to the weight minus my 36 sine of my angle. But we already figured out the angle, so that's good. And we already figured out the weight, so that's good. So this is 157, because I'm rounding, newtons minus 36 sine of 56.3 degrees. So I got 157 minus 30. I'm going to end up with 127 newtons is going to be the normal force. Now, another thing that he recommends, Dr. Hickey recommended, which I thought was, well, I can see that, and I can explain why I can see that, is let's say you plug these into WebAssign, and WebAssign goes, nah. Well, odds are, this is probably where WebAssign would give you the buzzer, because we didn't write this equation out correctly. What he suggests doing is instead of going back and looking at the work you already did, is hide that work. And then repeat. Because if I've forgotten to multiply by a 2, or if I've forgotten a minus sign, and I'm following my steps trying to look for that mistake, odds are my brain is going to fill in that same mistake and you're not going to be able to find your mistake. One of the things I suggest is go ahead and do these write down these intermediate calculations. Because right now I'm telling you guys I have no idea how most of you look at the problem, do the calculations, scribble on a scribble note, and not be able to follow the problem. and do it on the computer. I like to write down these intermediate calculations because when I go back and check, did I punch it into the calculator right? Did I actually do 2? I thought I hit the 0 and I didn't, and I get 2 divided by 36. And if I write down that number, that intermediate step, instead of just going ahead and multiplying it out in my calculator, if I were to see that that was 0.05 and you're going, wait a second, 20 divided by 36 is not going to be 0.05. I already have a place that I know I did fumble fingers on my calculator. So that's another way to check the problem. And we're about to give you, as we start into the next chapter, we're about to give you some more tools that'll allow you to do a problem a little differently. Okay.